Okay. I recorded second period yesterday, so I have one for all of the days. Okay. All right. So I'm going to start. So these are the trig functions that we already learned about. So if I look at this trig function, if I labeled this would be negative pi over 2, negative 1. This would be 0, 0. And this would be pi over 2 and 1. And my domain here, if I went left to right, would be negative pi over 2, pi over 2. And my range would be bottom to top, so it would be negative 1 to 1. And if I did the same thing on the cosine, if I labeled these, this point would be 0, 1. This point would be pi over 2, 0. And this would be pi and negative 1. So the domain would be, for this one, going left to right, would be 0 to pi. And then bottom to top would be negative 1 to 1. And if I labeled the tangent, the 0, 0 point's not going to move. And this point is pi over 4 and 1. And this point was negative pi over 4 and negative 1. And the domain left to right, because of the asymptotes, is negative pi over 2 to pi over 2, but we don't include them because of the asymptotes. And then bottom to top was infinities, so it's negative infinity to infinity. Yeah.
How come we always go from like graphing to not graphing to graph?
How would you like to do it? Because if I graph, you guys would stop at about graph. So if I graph a little bit and then we do something else, and we graph a little bit and I do something else, so chances are I get more if I spread it out than if we do it all at one time. Okay, so what we're going to look at is the inverse. And the inverse is written like this: the inverse sine, the inverse cosine, and the inverse tangent. And so when we do the inverse of anything, that means you just switch the x and the y. So if I just switch the x and the y, when I graph this, my negative pi over 2, negative 1 becomes negative 1, negative pi over 2. We just switch them. So this point is negative 1, negative pi over 2. Yeah. Sorry. Yeah. This stays 0, 0. And this becomes pi 1 and pi over 2. And since we switch the x and the y, we also switch the domain and range. So it's negative 1 to 1 and negative pi over 2 to pi over 2. And the cosine, if we switch this is going to be 1 and 0. This is going to be negative 1 and pi. And this one is 0 and pi over 2. And if we switch the tangent, the pi over 4, 1 is going to become 1 and pi over 4. And this side is negative 1, negative pi over 4. And the 0, 0 doesn't change. So if I'm going to draw this on the unit circle with these restrictions, since the range of the sine and the tangent are negative pi over 2 to pi over 2, this is what this looks like. So this is going to be what your sine looks like. And we're going to have all of our positive values up here and all of our negative values down here. And this is the cosine of theta, because this one is restricted from 0 to pi. And since the cosine is my x values, it's positive on this side and negative on this side. So another way to say inverse sine and inverse cosine and inverse tangent is arc sine, arc cosine, and arc tangent. It means the exact same thing. No. This is the inverse of the whole function. It's not the secant. It's not what you're thinking. The whole thing. Right. So the secant is just the inverse, like we just put 1 over the cosine. So this is, we're actually flipping the x and the y. Okay? Yes. So these all mean the same thing. So the inverse sine, did you guys hear that? That's a good, I didn't bring that up in my second period. So when I say inverse sine, I'm not talking about cosecant. The cosecant is 1 over the sine, but here I'm actually flipping the x and the y, not just the y value. So they're not the same thing. Okay? All right. So let's write this down next. Make yourself a little chart. Yeah, wait, yeah. This is square root of 3, sorry. This one's the square root of 3. Let's make sure you get it right. Yeah, sorry. Okay, so these are the values in the first quadrant. So the cosine at pi over 3 is a half. The cosine at pi over 4 is the square root of 2. The cosine at pi over 6 is the square root of 3 over 2. So we've memorized these, but you're going to want these for your homework, okay? All right. No. No. It is easy. What we're going to do is easy. Okay, yeah, either on the back or on the blank sheet of paper, whatever you want to write on. Okay, so here's what we've been doing. This is what we've been doing all along. And that you're going to want your little chart because I'm sure some of you have not. So if I ask you the sine of pi over 2, the sine at pi over 2. So the sine is the y value 1. So this is 1, right? Okay. If I ask you for the cosine of 5 pi over 6, it's right before you get to pi, correct? So that puts this in the second quadrant. So first of all, what is the cosine of pi over 6? square root of 3 over 2. And in the second quadrant, your x is positive or negative? Negative, so I get a negative square root of 3 over 2. So if I ask you for the tangent of 2 pi over 3, first of all, where is 2 pi over 3? Which quadrant, Angie? So this is 60. 2 times 60 is 120. So that puts this over here. So what is the tangent at pi over 3? It is the square root of 3. So, but over here, the y is positive and the x is, so the tangent has to be negative square root of 3. So this is how we've been doing this all along. I gave you an angle. You gave me a value. I gave you an angle. You gave me a value. The way the inverse works is I'm going to give you a value and you have to give me the angle. So I'm going to give you the value. You have to give me the angle. And the way I'm going to write it, it's going to look like this. So before we start, write this down and it'll help you. So this is going to be for sine and tangent, because this is where it's restricted for the sine and the tangent. So if I have a positive value, if I have positive, I'm just going to use my reference angle, right? Whatever the reference angle is. If I have a negative value, I have to use the negative reference angle. And that's what we wrote on the front, on the blue. We went 0, pi over 6, pi over 4, pi over 3, 0, negative pi over 6, negative pi over 4, pi over 3, negative 2. So positive up, negative down. Okay? For the For the cosine, we go from 0 to pi. Here's my pi over 2. These are my positive x angles, and these are my negative x angles. So this is my reference angle, and this side is pi minus my reference angle. Correct. So this is how you read this. The inverse. So you say, where is the cosine 1/2? Where is the cosine 1/2? So the cosine is 1/2 at pi over 3. Pi over 3. So the cosine is pi over 3, so this is pi over 3. If I wrote this, where is the cosine 1/2? It's still pi over 3. What? It's, yeah. So now I want to know, where is the cosine of negative 1/2? So it's a positive 1/2 at pi over 3. It's a negative 1/2 at pi minus pi over 3. So how do I take pi minus pi over 3? Same denominator, so I'd say 3 pi over 3 minus 1 pi over 3, and that would give me 2 pi over 3. I want to know where the sine is a negative square root of 2 over 2. So where is the sine square root of 2 over 2? it's at pi over 4 positive, but I want negative, so I have to say the negative pi over 4. Where is the tangent 1? Pi over 4. If I ask for negative 1, it would be negative pi over 4. Is everybody, we're all copacetic? Okay, so where is the cosine? A negative square root of 3 over 2. So where is cosine restricted? There is no negative pi over 6 for cosine. If I want the negative value, I have to take pi minus the reference angle. So if cosine is the square root of 3 over 2 at pi over 6, then I have to take pi minus pi over 6. I have to have common denominators. So I get 5 pi over 6. Are we good? So if we have quadrantals, the inverse sine of 1. Where's the sine 1? Just think about the circle. Where is y1? Pi over 2. Where's the cosine 0? Okay, think about it. So the cosine on the circle, where is it equal to 0? It's at pi over 2. Okay, before you start answering this one, where is the tangent 0? And the tangent is y over x, so the y has to be 0. So where is the sine equal to 0? Sine of pi over 4 is square root of 2 over 2. Where is the sine 0? If you draw your circle, where is there no y? Right here and right here, right? But it has to be 0. 0, because the sine is restricted to these two. So you can't use this one. You have to use this one. Okay, so there's also, you could write this. This is an inverse of the inverse. Kind of, it is. It does. It looks harder, doesn't it? So where is the cosine 1/2? Where is it? Pi over 3, right? So then it says, what's the cosine of pi over 3? It's 1/2. So this one, it's exactly the same, correct? So what you were saying, because it's the inverse of the inverse, it's the same thing. But it only works if it's in the restricted area. If I give you something that's outside of the restricted area, this doesn't work anymore. Okay? So if I gave you this, so these are the same, right? Tangent, inverse tangent, it's 3. So before you can answer this one, is 5 pi over 6 in the restricted area of cosine? Yes or no? So cosine is 0 to pi, right? Is 5 pi over 6 before pi? Yes, so this is correct. This is 5 pi over 6. But what about this one? Is that in the restricted area? No, it's not. So I'm going to look at my little circle. So my negative pi over 6 is down here, correct? This is my negative pi over 6. But it's outside of my restricted area, so I can't use negative pi over 6, and that doesn't give me the answer. And I'm using cosine. So my cosine is my x value. So is the x positive or negative on this side? Positive. So would it matter if I used a positive pi over 6? Because that's still going to give me a positive cosine value, correct? So this one is pi over 6. So if it's outside the restricted area, you have to make it so the sign would be the same. Not the sign in front of the pi over 6, but the cosine sign. The negative pi over 6 gives me negative, but I have a positive cosine value, and the reference angle is negative pi over 6, so a positive pi over 6 will still give me a positive x. Yes? Correct. Yes. And that's what we did. It's on the blue sheet on the front also. So these are the restricted areas. Correct. For your cosine and for your sine and tangent. So this is not between it. So, but I know at my minus pi over 6, the cosine is, the x is positive. So I know this reference angle of pi over 6 would be okay. So what if this was, let's say for instance it was a negative pi over 6. I would have to use it over here, right? I'd have to find the angle over here to put it back in the restricted area with a negative x. Okay? All right. 2 more I want to show you and then we'll be done. So this one, if this said cosine inverse of a half, the answer would be 1/2. But what does the secant do to the cosine? It flips it, so instead of 1/2, you get 2. Okay, so for this one, is this on our chart? Okay, so I'm going to draw a little, so I have to have 4 over 5. So that makes this, my x value is 4, my radius is 5, and what does that make your y value? 3, because it's a 3, 4, 5 triangle. And I want the tangent of this. The tangent would be y over x. So I'd have 3 over 4.